First off, you guys, did you guys understand how to do 1969-6? What it was asking? Everyone take a look at 1969-6. What is that asking you to do? No, that's what it says. What is it asking you to do? Yes. What that question exactly is asking you to do is, hey, I have the function y equals 8x to the 8. What's y prime at 1/2? That's what that's asking you. It's the difference quotient. It's old school what we did in chapter 2. y2 minus y1 over x2 minus x1 at 1/2 and 1/2 plus a little value. Does that make sense? So the question is, how do you do this without a calculator? Yes? So this is why it's a 1969 question and not a 2010 question, because they don't really care about doing all of this like without a calculator. That's like more interesting, I think more challenging questions. Or this is like, can you multiply? Is kind of what it's asking. You know what I'm saying? Well, let's figure it out. So the derivative is going to equal what?
64x to the 7.
64x to the 7. So then you got to plug in your 1/2 into this. So that's like, how do you figure out what this is? Well, here's what I would do. Okay, so you can seventh each of these separate, but here's what I was thinking of. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6th is 64. So I would say this is this to the 6th, where this is 1 over 64. You know what I'm saying, guys? And then those would cancel out, leaving you just with 1/2. Does that make sense?
No.
Sure. So so I just split up the 1/2, because it's raised to the 7th into 1/2 to the 6th. Same base, add your exponents. And why I did this number is okay, because you can say this is the same as this. 1 to the 6th is 1, and then I went 2 times 2 is 4, so 2 is... So I built this up to 64 so they would cancel out. Okay? So then these are canceled and just leaving you with what's left over. So you're really not going to see a question like that, or like, yes, you can multiply on the test in the last 15 years. But still an interesting... Like, the goal is, like, to understand the notation. That's what's important about... analyzing that. So what question did you ask, Katie?
The absolute value.
So absolute value, kind of another, a lot more pre-calculus back in the day. What number did you say? There it is, 18. So going back, old school, we're going back to last year. Absolute value of x looks like this. Boing. What does the absolute value of x minus 3 look like compared to absolute value of x? Absolute value of x minus 3. That moves it right. And then what does plus 2 do? Moves it up. So this is shifted right 3 and up 2 for this. So I can do that. Shift right 3, up 2. There's your graph. That's what you're dealing with. And it's a corner. Do you see it? At x equals 3, you got a corner. So the derivative doesn't exist. Does that make sense? Yes?
If it was not 3, would you still be able to find it?
Yeah, if it was at x equals 4. You guys, what's f prime of 4?
0.
1.
What's f prime of 0?
Oh,
Yeah, it exists everywhere because it's always a constant line. So it's a slope of this line which is 1, and then the slope of this line which is -1.
Is there like a rule for finding the absolute value function?
No, you usually, like, it's interesting because there's going to be another one, I think, somewhere on this packet, and you just got to treat it like, is the output going to be positive or negative, so you can just drop the signs. You know what I'm saying? You can either treat the two different cases. When it's positive, it follows this rule. like what you can do is, when this is positive, drop the signs. When this is negative, make it the opposite of what's inside. And then just treat it like whatever it is. Does that make sense? There's no specific absolute rule. It's just like if it's positive, you just get rid of the signs in that area. If it's negative. And in this case, it's right where it starts going, because at 3, just to the right, it stays positive, but just to the left, it's negative. And that's why it's right on that little corner. Does that make sense? That's why it does that at 3. Cool? Okay, any other questions on these? Okay, maybe some individuals. But otherwise, I want to get cooking back on the packets we've been working on. Let's hyperdrive back to 19. We're all at different places on this. Can everyone work on a problem? Can everyone try 1998-87?
All the way down here.
It's on the last page. It is a calculator question. 87 on the 1998. Try that one in your group. Number 87. Anyone?
Bueller.
Yeah.
Yes! Thank you, David. It's asking for the equation of the tangent line. You need 2 things for the equation of the tangent line. What are they? A point and a slope. What do you have? You don't.
You have a slope.
You have a slope. Oh, but we have an x value, right? Because then with an x value, you can plug that in to get the y. You don't. This is backwards from anything we've ever seen. This is what they teach now. The 1990 tips is you don't have the x value and figure out everything else. They just give you the slope. They give you f prime of x equals 1. What the heck are you going to do with that? That's not what we usually do in this room. You give me an x, and then I solve for the y, and then I plug that x value into the derivative, and then I get a slope, and then I plug all that into point slope. Think about it. What do you do? Wow. Ooh, I like
So 4x.
Talk about it in your group. How do you figure this out?
Just find an x.
I'll give you my money.
I didn't give it a short.
Then you just.
No, I just said.
Okay, I got the point.
Since this is already the slope.